I suppose without further ado, the topic that we want to talk about today is how to de-risk a self-driving city. So I think we all are starting to understand that we've got an integrated environment of sensors, vehicles, and stakeholders that are all going to be working together in what we think of centers in a municipal environment, and we need to de-risk that entire environment. We need to make it ultimately so that it's a zero fatality zone, unlike today where traffic deaths are by far the largest cause of preventable death in the world, by far. I mean, they're in the same order of magnitude as cancer, maybe like 20% as much. And you can understand everything that's going on in the space of self-driving cars. You can see every agent. It means something's missing. When we can track objects, something's missing if we can't prevent traffic fatalities. So I'm going to start talking about how we do that and how we think about that problem. What I want to start with is something that AIPod is working on right now, or I should say AIPod are working on right now, which is what we call our situational awareness tool. So what you can see here is, on the right-hand side, a 3D LiDAR map on which we project a number of different entities, moving entities, cars, pedestrians, bicycles when they come up. This is the US, so we don't see as many bicycles. But in any case, whatever it is that's there in the environment that's a traffic object of interest, we project. And then on the left-hand side, you can see the source of that data. And then down below, what you can see is a real-time database that we're creating that allows you to query anything you might want to know about what's going on in the environment, all the way down to jaywalkers that might be doing something that's maladaptive. On the bottom right-hand side, you see our analytics environment, which acts as a database. You can move the mouse around and query in real time things you're interested in. There, we're pulling out just pedestrians. And then we can scroll over and start looking at all the tracks that have happened here in the last 3 hours. And you can see that tracks end up appearing colored in the two different windows, so you can understand, say, for example, the timing that different jaywalking events happen. What I want to do now is describe how we can use this kind of valuable data that we're getting all from around the city of Pasadena and soon from other municipal locations to start understanding traffic well enough to really truly de-risk it. So this is a scatter plot of all of those data, that type of data I just shown a second ago, cars, pedestrians, bicycles, and other events in this one particular intersection. And you can see that cross shape describes all of the different trajectories that they're taking. But when you think about the data that are coming in from AVs, when you can think about all the value that you might get out of it, the way to parameterize it is not simply in cars, pedestrians, bicycles, and so on. You really want to understand it in a larger set of groupings if you want to start making predictions about what's going to happen. If I want to take what happens at this intersection and use it to predict what's going to happen at another intersection. So now I'm going to dive into something that really excites me, and it's not going to seem like it's about saving lives right away, but I hope we'll get there, because it's all about data, schema, and ontologies. Bear with me, please. It might not make sense to just think about all of the events that happen in the traffic space in an actual Euclidean space. Instead, we can start thinking about these categories that we assign as other kinds of attributes among many other possible kinds of attributes that we would want to assign. Say, for example, the zones or the legal boundaries in which these objects move, whether they're accelerating or decelerating, parking or leaving a parking space. And then ultimately, how they interact with each other will also become parameters. And all of these parameters interact inside of what you can think of as a big and flexible database. It's not always easy to know how they should be, what the hierarchy should be, whether you should care about the zone first, or whether you should care about the identity first and then the zone. In fact, the question that you're asking may necessitate different kinds of hierarchies. So you might need a kind of a flexible way of thinking about these data so that you can ask many possible questions, or you can have the data jump out and tell you what's important about it. So let's see what that would look like. In order to know what this intersection is, for this intersection to tell us who it is, we can let it transform. I'm going to use my transformer sound. I'm going to go. Come on, transform. There we go. And now we have what I would call a little bit closer to the identity of this intersection. It's not parameterized by, the 4 trajectories that go in and out of it. Really, its identity is more in the quantities of all of the events that happen inside of it according to this particular schema that I've chosen. So what you can see here is this particular intersection has a lot of things you would expect. It's got pedestrians, bikes, and cars, a lot of all of them. But it's got a lot more cars than pedestrians and more of both of those than bikes. Again, this is the US. I'm sorry. We do have more bikes than other parts of Los Angeles and Pasadena. Anyway, we can also see this intersection has got a lot more stuff going on in the right lane and some turnings happening in this turning zone than it does potentially in other lanes. I happen to know this intersection leads onto a highway if you take a right from it, so it would make sense to me that a lot of people would be taking a right. And so when we now think about how we would want to generalize from this intersection, we're really looking for other intersections that have these kinds of properties, more so than their particular geophysical coordinates. If we add risk to this data, we get another dimension that can be particularly useful for generalizing. So let's do that. So now we're going to overlay risk. And this is created according to a risk score. We're evolving the way we think about our risk scores a lot. And there are many ways to think about it. But basically, it's danger to human life. And we're not recording enough data that, thankfully, that we are getting a traffic accident every day. In fact, we can parameterize risk to human life before we ever get into the traffic accident. It was something that we can think of as a near miss. And so these events are times, say for example, when a car comes really close to a pedestrian in a way that's just uncomfortable and should be better. And we can sum them up and color all of these events by essentially their risk and start to see the patterns that exist here. So what you can see is that, the pedestrians on the sidewalk don't have a meaningful amount of risk at this intersection. Right in the intersection, there's some risky activity. And this right turning thing has also got some unusually risky activity. We can, if we want to, kind of dive in and see a particular example of that. So we'll go and select that one outlier right there. And we'll just highlight what I'm selecting. So this is involves a car turning right into a north side street, an intersection. This is projected back onto the original intersection, and you can see, by the way, the projection of the entire risk space and the intersection. You can still sort of see what's going on, but it's a little bit more muddled. And now we can dive into this individual scenario and see what actually happened. So click on it, say for example. And you can see that this is an example of a near miss. A car almost hit a pedestrian, and then the pedestrian sort of communicates in some way with the car. They decide the pedestrian can go and do what it was doing. That kind of data is, by the way, conspicuously missing from nationalized accident reporting. So it's the kind of thing where if you're recording from enough cameras, you can really develop a lot of deep knowledge about what's sitting inside the iceberg underneath the water. Now, the real risk space is probably a little bit more like this. So again, I've been showing something that is in the hundreds of events types. But once we've actually parameterized the entire risk space and aggregated it all together, and I don't think it shows up in the video, but this is hundreds of thousands of different events. And they're all clustered according to these high-level ideas. When we have eventually combined the different kinds of sets of data that we're looking to combine, from nationalized accident reporting to the kinds of video that you've just seen, to other kinds of data, including engineering knowledge, specialized engineering knowledge that we hope to get, and create a risk graph that includes not just current vehicles, but also AVs, and a risk graph that'll end up evolving. It'll probably be at least this big. And then we'll be able to do something else with it that involves more than just understanding the current environment. We'll be able to use it to test AVs. So we'll be able to, for any one of these hundreds of thousands of nodes, go and select it and offer it to an autonomous vehicle as a scenario that will need to either pass or fail on. So for example, does an AV with this complicated set of cars and pedestrians, accurately navigate this scenario? Some will be able to, some will not. We can use that as a way of parameterizing how good the AV is at doing its job. and by presenting exactly that directly to its cameras and the equivalent to its LiDAR feed and whatever, the whole sensor suite that it has. Fortunately, that's the complicated part. There's only 4 controls in the output of most AVs. Thankfully, the problem is at least that simple. And then we can also scale up to the somewhat more risky side, where you do the exact same thing, but in heavy fog. This, as many will recognize, is a simulation done in RF Pro, which is one simulation tool that we plan to use a lot of in the context of de-risk, which is a collaboration now between us, that is to say AI-Pod, and also Imperial College London, Claytex, and DG Cities, and Transport for London. And all together, we are going to do a version of what I've just shown you in microcosm and macrocosm. We're going to be combining a truly large amount of data in order to try to come up with an actual knowledge graph that describes the entire transportation space, including AVs, and then feed it back to self-driving cars in order to be able to test them and validate them to drive safely on Britain's roads, and eventually other roads. So I've just said everything that I wanted to present in these slides, but I'll go over the bullets anyway. So this was, by the way, a grant from Innovate UK. Quite grateful for it. Quite proud that we've all were one of the winning bids. And very grateful and proud of our collaborators. This is just too much to read right now. I'll just leave this on the screen for the end. And the goal is, of course, to take what is now risk-laden roadways and transform them to roads where all driving is defensive. So with that, I think I'll open it up for questions. Questions?
Thank you, Jess. That's really interesting. What are your next steps beyond the piece of work that you just described? Looking forwards a year, 5 years, where do you see it going?
The interesting thing about the work we just described is it's and this is an important part of our bid process, it evolves. So we plan on having a version of this running quite soon. According to our first deliverable is in January. We should be able to test, do a highly representative set of tests in AVs, we think, at that point. And then it'll get richer and more complex over the next 2 years. Now, I think one of the really interesting things about this project is that it starts out by just characterizing the space that AVs have to drive in, which means that we start characterizing the risk space in the first place, which, as we've started talking with people, we've realized nobody has really done it a comprehensive way. Now, that's a bold claim to say that we're going to do it in a comprehensive way when others haven't. We are. But I think there's a lot to it that makes it possible right now when it hasn't been possible historically. One thing that we think a lot about is insurance. Many in this audience are interested in that. Insurance has always looked at things in an exclusively actuarial way. And I showed actuarial data in a sense here. Any kind of historical accident reporting is basically what they look at, except for they have proprietary versions. But we can do something that they can't. We can record in real time in a way where we get these near misses, so data at higher fidelity. And then we can also simulate. And we can simulate not just what's going to happen with autonomous vehicles, but what's going to happen with regular vehicles in new and unusual situations. And putting those tools together, we think it's really possible to create a knowledge graph for everything that happens on the streets that could inform a true zero traffic fatality future even before autonomous vehicles arrive. And so, or arrive in their full flowered form. And so I think our goal is going to be to make that happen. Nobody wanted such an extensive answer. They're not going to ask any more questions. Please.
So I just wanted to ask, have you, I'm assuming that all of this data so far is relating to vehicles that are not AVs. So what about when you start to introduce...
Well, there are a lot of Teslas on California roads. So where have you put those? But yeah. No, go on.
Yeah, so I just wondered how you think the dynamics and the shape of that that plot that you showed after you transformed could begin to change as we see more of these vehicles coming onto the road?
We, I think the real question is before they're actually on the road, how can we change the plot? And I think the answer is we have a couple of different tools at our disposal. So one of the things that we have by virtue of where we're from is we've got all these engineers from the Jet Propulsion Laboratory, which is this NASA lab that is used to putting robots on Mars. And when they do that, they've got one shot at putting something complicated that is sort of like a self-driving robot on a distant planet that's 5 minutes away by the speed of light, and 5 light minutes away. And they've only got one shot, and they've got to guess everything that's going to go wrong beforehand. So the way they do that is with a sort of a structured brainstorming process. It has a bunch of different acronyms, but it's basically you sit down in a room and in a structured way go through everything that's going to happen over and over and over again and have a way of formatting it. And we can put that same kind of data into the knowledge graph, and then you can sort of do a product. You can take what happens, it was already happened in the real world, and literally do a product between that and the expectations that you put in from your structured brainstorming. And what you see is some weights going down and some weights going up, and the shape changes. And I can't predict exactly how it's going to change. It has to come out of that process. But so that would happen. Please.
I wanted to ask how you might deal with the difference in how vehicles and drivers will behave in different countries, and whether you're looking at building models like that for behavior in different countries, or you're just looking at the US at the moment and the UK?
Of course, it is of great interest how they're going to behave in different countries. We have insights into 3 countries right now. England, and just London by itself, I mean, that could take like that just could dominate a lifetime if we weren't careful. So it's so much more complicated than anything in the US, at least that I've been able to measure, which for us is good. I mean, that excites us. And we got some insight into the US. And then we have a lot of insight into India, which is a completely different story because of some special expertise inside of our company. I would suspect that our main focus is going to be to nail something that's really, really complex, like the City of London first, and then hopefully take those learnings about how to capture it and move on. And I don't know exactly who the first buyer is going to be, but it'll be driven by whoever that is. All right. Thanks, everyone.